We have been taught that stealth is a game of shapes and materials. If you angle a fuselage correctly and coat it in radar-absorbent paint, you can become a ghost in the sky. For decades, this was the ultimate tactical advantage, defining the air superiority of the modern era. But that advantage is currently evaporating. We are entering the era of quantum sensing, and it is about to make the entire concept of invisible hardware obsolete. To understand why, you have to understand how traditional radar works. It is essentially a shout and an echo. A radar station sends out a pulse of radio waves. If those waves hit an object and bounce back, the station hears the echo and knows you are there. Stealth works by either absorbing that shout using carbonyl ion or foam, or by reflecting the echo away from the listener so it never returns to the source. But quantum radar does not shout. It entangles. Imagine a pair of twins who are telepathically linked. No matter how far apart they are, if you pinch one, the other feels it instantly. In quantum mechanics, we call this entanglement. A quantum radar creates a stream of entangled photons. It keeps one half of the pair inside the machine, the idler photon, and sends the other half, the signal photon, out into the sky. Because these two particles are linked, anything that happens to the signal photon is instantly reflected in the idler photon back at the base. Traditional radar struggles with noise. In a storm, or when an enemy is using electronic warfare to jam frequencies, the sky is filled with random radio energy. A stealth aircraft uses this noise to hide its tiny, weakened echo. But a quantum radar is immune to noise. The idler photon only reacts to its specific entangled twin. It doesn't matter how much jamming or chaff is in the air, the radar station is only looking for that one specific subatomic link. If a stealth fighter passes through that stream of photons, the link is disturbed. The idler photon back at the base feels the pinch, and the ghost is revealed. There is no paint thick enough and no angle sharp enough to hide from a link that exists at the level of quantum states. This goes deeper than just finding aircraft. This technology is the key to the next generation of navigation in what we call denied environments. Currently, almost all autonomous systems, from drones to the phone in your pocket, rely on global positioning systems. But GPS is an incredibly weak signal, often described as the equivalent of a 60-watt light bulb seen from space. It is easy to jam, easy to spoof, and impossible to access underground or underwater. If you are operating a tactical system in a contested zone, losing GPS usually means the system becomes a blind, expensive paperweight. Quantum sensing provides what we call a quantum compass. By using cold atom interferometry, we can measure the tiniest changes in gravity and inertia with such precision that a vehicle can know its exact position on Earth down to the centimeter without ever needing a satellite signal. These sensors trap atoms in a vacuum and cool them to nearly absolute zero using lasers. At this temperature, the atoms act as waves. By measuring the interference patterns of these waves, the sensor can detect the rotation of the Earth and the pull of local mountain ranges or seafloor trenches. It is navigation by the very fabric of space-time itself. This shift is a total reset for tactical engineering. For the last 50 years, the goal was to hide. For the next 50, the goal will be to see through the interference that blinds everyone else. We are moving toward a world where stealth does not mean hiding from radar. It means being the only one in the room who can still operate when the lights go out and the signals are cut. The transition from classical sensors to quantum sensors is the most significant leap in engineering since the invention of the transistor. It is the end of the invisible era and the beginning of the transparent one. This is how we ensure resilience in environments that are designed to be hostile to technology. The future is not just about faster computers, it is about sensors that can feel the heartbeat of the universe itself. If you want to understand how this new battlefield is being mapped, stay with us. The era of the ghost is over.